Hi, my name is Ashley Touchton, and this is my Physics 3 lab. Hi, my name is Ashley Touchton, and this is my Physics Lab 3. I began by tipping over a cup of water and watching the water move across the concrete at a constant velocity. I then imported this video into Tracker so that I could track the path of the water and find its velocity. I added in these axes and this scale to keep the distances the same throughout. I then played the video, and at the same time interval, which as you can see here is 0.034 seconds, I put on this x-axis points where the water had hit, which you can see correspond to the positions listed here. I then took this information, which corresponds to this graph here, and you can see that, as you can see, it's almost completely straight, meaning that the water was moving at an almost constant velocity. Most of that error is due to human error in where I clicked on the screen. And I imported this information into an Excel spreadsheet, which, as you can see, corresponds to the points here on this blue line. And I found the line of best fit in order to find the slope, which in this case is 0.4937, which is the velocity that the water is moving at. I then used this information in my Python code, the same as I used the starter lab that we used in lab 1, and I changed my position vector to be my starting position, which is 0.0220, which you can see here, and my ball velocity, which I just mentioned, was the slope of this line, which you can see here. I also changed my delta t to be the time interval that I used, which was 0.034 seconds. And I made sure that my time interval was the same as it was in the water, which is where t is less than 0.4 seconds. It's important to keep your origin at 0, as I did, because that's where the water is starting to move from. However, if you change the origin to be something else, it still will keep the same slope and show the same velocity. However, the graph will shift, and if it shifts too much, it will have too large of an error to still be accurate. I then can run my program, and as you see here, the ball moves at the same speed and the same distance as the water moved across the pavement. You also can see here that these points, that this movement corresponds to this graph shown here. And I extracted these points and put them back onto the Excel sheet, which are these points shown here, and those correspond to these orange dots shown here. And the big difference in this line and the line that I tracked in my video is, again, due to human error and due to the fact that the water is not moving at quite a constant velocity. This is due to the fact that the net force is not 0. In an ideal world, such as the orange dots shown here, the forces pulling down, such as gravity, and the forces pushing back up, such as friction, would completely cancel out, and the net force would be 0, causing the water to move at a completely constant velocity. But since this is not completely the case due to things such as the porosity of the ground and the leaves that are in the way that interfere with the water's movement, cause the net force to not be quite 0 and the line to be just a little bit off. Thank you very much.